Hi. In this video, we are going to review the IFM sensor and then proceed to test its calibration. First, we examine the packaging. It says designed by IFM, made in Romania, and the model is VKV021. The packaging seems to be original. In the first step, we take an overview. The sensor has 4 pins. It features an analog output from 4 to 20 milliamps. It is labeled as follows. Top left pin and top right pin are for power supply. Top left is positive supply, bottom left is negative supply, and bottom right is the relay output, which is PNP type with 500 milliamps output current. Here we see 2 adjustable parts. One is for the set point and the other is for delay. Let me explain these. There are 2 movable elements. The first one adjusts the set point, the vibration threshold at which the relay activates. The second one is for delay. To adjust them, first unlock the mechanism. When the sensor is installed on site, you should keep it locked to avoid accidental changes. To unlock, grab the top part and turn it until it aligns with the arrow, then it becomes movable. This sensor, VKV021, has a reading range from 0 to 25 mm per second, which is equal to 1 inch per second. The scale starts from 0 at the top and increases down to 25 mm. You can set the set point anywhere within this range. For example, I set it to 5 mm per second. That means if the vibration level reaches 5 mm per second, the relay will activate. Now, there is another setting labeled Sec Delay Set Sec. What does this mean? Sec is related to the top and bottom charts, and this sets how long the vibration must stay above the set point. The values range from 0, 10, 15 to 60 seconds. Short spikes are usually not real failures. For instance, a person may touch the sensor, or the machine may briefly generate a vibration spike. Real failures, such as bearing defects or shaft looseness, typically cause gradual vibration increase. Therefore, I configure the delay so that if vibration exceeds 5 mm per second for 20 seconds, the relay will trigger. There are 2 indicator lights, one is for power and the other shows relay status. One turns green and the other turns red when the relay is active. Another point, this sensor does not use piezoelectric MEMS technology. Keep in mind that MEMS is generally cheaper than piezoelectric and is more susceptible to noise.